of your IAs are of a similar vein. What's the effect of changing the van der Waals forces or the carbon chain length on some enthalpy or entropy value? Am I correct? Yes. Okay. So maybe our opportunity or our problem is, how do we link those two together to make it the reason why we actually made our internal assessments? Yeah. So the effect of temperature on KSP on the solubility product, which is used in Chem Collective, which I showed you at the beginning of this sequence of lessons. Okay. And she's decided to link it to heat packs, and that's a real-world application about how her study can actually be put into context. So how can we put our research into context other than saying, Mr. Midgley said, use WebMo and use John Chewy and make an IA? What's going to be the tenuous link or the wonderful link between those things that we have studied? Anybody have any ideas or come up with some rationales as to why our research question is important to anybody? That's a start. What's the point of any research? Why do chemists research stuff? What are we trying to do? What's the point of science? Okay, that's one thing. That's the point of philosophy as well. What's the point of chemistry? The point of chemistry is understanding the world around us, trying to link the internal mind with the perceived world and all that stuff. Why is the sky blue? Why is copper sulfate blue as well? Why do we care about van der Waals and molar enthalpies? Because we want to extrapolate. We want to be able to predict. And if you have a range of compounds and you can predict some new compounds as yet undiscovered, then that's the whole point of doing chemistry. Don't forget, Mendeleev in his periodic table predicted the existence of elements which had not been discovered yet. So that's the whole ethos, the whole reason for being, the nature of science, if you like. That's chemistry. You may well think of your own reason for doing this. It could be extrapolation to a new value, an unknown compound. It could be interpolation for any that you've missed on your journey through looking at them. Okay. It could be for you as a student to have a deeper understanding of the link between the area of the molecule or the forces within the molecule and the enthalpy that you get from, or the energy that you get from that molecule. Okay. So hopefully those serve to give you a little bit of inspiration about what you could include, but also you can also think perhaps of your own. Numa surprised me by coming up with the heat packs thing for her personal significance in the world. We need to put it into the world. Okay, so little introduction, a few sentences. Research question. You've all got a good research question. You need a couple of sentences after that to say why your research question is important. So hopefully that's given you a few ideas on what to do. Background information. So there is tons, there's absolutely tons on van der Waals forces, or on strain energies, or on energies of molecules. What are your go-to sites to look at for information to put into your internal assessment? Where do you go? Mia, what do you look at? What sites do you recommend to the rest of the group? What do we want to see? We want to see that you understand the chemistry. Okay, we don't want waffle, we just want to see some chemistry. What can we see in Numa's IA? Well, I can see in-text referencing. It doesn't matter which reference system you use. You can do in-text or you can do Harvard referencing or whichever you want to do, as long as you are consistent. It just says an appropriate referencing system. We've got some equations. We've definitely got some chemistry. We've got some state symbols. I want to look at the chemistry, and that's really good. I like the look of that. There's no waffle. There's no filler in there. And also, this is above and beyond the syllabus because KSP is not on the IB syllabus, so that's really good. What you're doing is not on the IB syllabus, so that's also really good. She then goes on for about 1.5 pages of an introduction, just showing the reader, telling the reader that she understands the chemistry behind what she is doing. Okay, we've got some higher level content. We've got enthalpy of solubility. We've got hydration enthalpy. She's probably talking about lattice enthalpy in here. Hydration enthalpy, lattice energy she is. So magnitude of solvation enthalpy, magnitude of lattice enthalpy, dissolution. You've done all this with Mr. Gardner in thermodynamics, right? A nice little diagram. And then she's going on to intermolecular forces. I would be expecting in all of your IAs to have something like that picture in your internal assessment. You can get it from WebMo. You know, if you go on the orbital box, the key that you hit for the orbitals, you know what I'm talking about, the blue and red thing. Hit number 1 at the top and it will show you the electron probability distribution throughout the molecule. Screenshot that. That is absolute gold for your internal assessment. More chemistry, how she's derived it. Now, this bit might be a little bit more complicated for your internal assessment. Why? Because we don't know the relationship between, or we can probably predict, have a guess, we don't know the mathematical relationship between van der Waals surface area and molar, whatever it is you're calculating. Yes, this bit about the equation or the mathematical relationship, you will only know after you've processed your data. Okay, you can get the equation of the line from Sheets or from Excel, whichever one is your preferred software package. But you can be putting that relationship at the beginning before you even discuss the variables. I'll share this with you, the actual IA, at the end of this little presentation. She's saying what she's going to calculate and how she's going to get it. She's going to get from the line of best fit from her graph. Now, independent variables. Please do, or all your variables, please do a table for variables and do a table for evaluation. Okay, so you're independent, what you're changing, you're all changing carbon chain length, right? Yeah, anybody not changing carbon chain length? You can leave it as that, that's okay, or you can change that into a surface area, or you could change that into Debye units for polarity. So think about how do you raise that level of, how do you raise that data treatment to include some mathematical rigor in what you are doing. Okay? But leaving it as 1, 2, 3, 4, 5 is kind of okay, but we can be a bit more sophisticated. Dependent depends on what you are calculating. I think you are going to calculate the relationship between van der Waals and molar X, Y, and Z, whatever it happens to be. So your dependent, though, is what you measure. So have you measured the enthalpy of formation, enthalpy of combustion? What have you measured? That's what you've measured. Control variables, how many should we have? How many control variables should we have? 6, awesome. Control variables are going to be slightly difficult in a database IA. What sort of control variables are you thinking of right now? Say it louder. Good, you're controlling the nature of the molecule you're looking at. What else? Oh, you kept it to primary, secondary, or tertiary, so the class of compound. What else? Yeah, which database you chose, and crucially, which one you excluded. What else? Oh, I like that one. I never thought of that. Thank you. How many times I got trigger happy on that little spanner on the side of WebMo? Excellent. We're at 4. Keep going. What else we got? Okay, so you were doing esters, so you kept it methyl, whatever it is, ethanoate, propanoate, butanoate. That's fine. If you control that within your group, so that's 4.5 stroke 5. Another one. What's at the top of John Chewy's site? Temperature and pressure is there. You control the temperature and pressure in John Chewy's site. That could count as 2. Okay, so we hit 6. We hit 6. If you didn't control them, what's the impact on the investigation? For this one, if you didn't control the salt, result in different KSP will not answer the research question. So you've got to control your experiment to answer the research question that you postulated in the first place. How will you control it? I will keep it at 101.325 kilopascals in John Chewy's website, or I will always keep it methyl for my ester, etc. Control, impact, and how it will be controlled. Why? Because your moderator is moderating on a busy day, weekend, 10 to 15 IAs a day. You could be number 15. You know, their partner could be waiting to take them out to the shop, and they're like, come on, hurry up. That they're human beings. And if they can just see, he or she has just gone, controlled impact, how it will be controlled, tick, 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 boom, they're on full marks. You're off out the door. Okay? Method. Always include a screenshot thumbnail of what package you have used. Okay? Not big, don't take up a full sheet. That's perfect. The moderator can see you've done the experiment, what the molarities were for here, pH plus and OH minus. And she's talked about how she actually went through it. Okay, we don't want to not necessarily have to say, I pressed guest login for Webmo, or I refreshed 3 times to make John Chewy's site work. I mean, that's honest reflection. I suppose it's not too bad actually, the second one. That's okay. But she's talking about what she trialed and what didn't work, as well as what she did and what did work, and why that was included in the internal assessment to answer the research question. Yes, she has used Wikipedia and Course Hero, which we didn't put on the X list here. But that should absolutely be on there because it's just an open public space that people throw things onto. But she has justified that because there was nowhere else that had any data whatsoever for what she was looking at. And she's told us in reading it that she's looked at NIST, she's looked at IUPAC, she's looked at the Handbook of Chemistry and Physics, and there was only very sparing data in there. So it's an honest reflection. Okay. So in Webmo, have a look at your NIST and your PubChem and your ChemSpider. There will not be enough data on there to answer your question, but you've looked, and that's part of your journey that you are recording in your internal assessment. She's gone on to there. Safety, environmental, ethical. You don't need to have them for a secondary data internal assessment, but she just said, just in case the moderator's an idiot, that there are no safety, environmental, or ethical considerations with this internal assessment. So after, how many pages was that? 3? 1, 2, 3 pages-ish. Then we finally get on to some results. Right, what's wrong with that results table, please? Critique that results table. Excellent, missing uncertainty. What else? Right, so sig figs all over the place. Look at the temperature. What's wrong with the temperature? Problem is, even on Chem Collective, suppose I know Chem Collective, if she'd have just done that, then she could have just done that. And then that would have been full marks for that column. Because in the package, I know that it gives 1 decimal place on the temperature, right? And she'd either just forgotten or she was rushed or whatever it happens to be. But the problem is, if it's no decimal places, then it's plus or minus 1 degree, so that's 1 over 20, that's a 5% error. Now it's a 0.5% error just because I've checked the data correctly. It's 0.1 in 20.0 rather than 1 in 20. Make sense? Okay. Some of your data, you're only going to be able to get the last decimal place. If you're staying with number of carbon atoms, it's going to be hideously difficult. You can't do plus or minus 1 on number of carbon atoms, right? You can't do plus or minus 0.1 on number of carbon atoms. That's not going to work. That's why I was saying at the beginning, if you can translate that into some form of surface area or dipole or Debye unit thing, then that will be enormously useful. Then we can go to the last decimal place and propagate the uncertainty like that. Independent variable, dependent variable, what we actually get are the temperature in K. Again, plus or minus missing, plus or minus missing, plus or minus missing, plus or minus. R2 is kind of the norm. There's no guidance from the IB to say it's got to be 3 sig fig, 2 decimal places, all that stuff. I've seen, and I think we'll see it here, it's a good question because when I look at the KSP, this is 10 to the minus 9. Okay? So she's saying that she's precise to 100 millionth of KSP, which is clearly bonkers, right? And in fact, there's a slight difference here, but once we get to like 10 minus 6, 10 minus 7, 10 minus 9, that's exquisitely small, unbelievably small. In fact, there's hardly anything there at all. It's infinite, almost infinitely dilute. And the thing which I would question is, why did she not use that as the range of data, so between 0 and 40, where clearly there is a gradation in values and there seems to be a relationship? Why don't you just do, like, I don't know, 0, 5, 10, 15, 20, 25, 30, 35, 40, that sort of approach, which you could have done, and then should have much richer data set. We'll see in the graph that this is not perhaps the best range that she could have chosen. Okay. Wikipedia, again, no uncertainties. Chemical data, but in Course Hero, just please, no. Qualitative data. You did not see the experiment. You did not see it happen. There is no way that you can say that you had qualitative data, but she's checked that the moderator knows this. Calculations. She's set this out really quite nicely, I think. KSP is just products over reactants, like you did with KC and KA and KB and all the lovely Ks that we all love dearly and called true. She's given an exemplar for the KSP. Okay, so 2 to 2, she's saying, 2 to 3, so there's 2 ceriums and 3 sulfates in one cerium sulfate. She's explained how she's done the solubilities. We do expect one explanation for each sum that you do within your internal system. Just one. Just one. And then at the bottom, it took me a while when I was marking this to find it. There is a calculation on how she's done the uncertainty. Largest to smallest KSP over 2 is used the half-range method. Okay. But she didn't get the mark. Why did she not get the mark? Because she didn't put any units with the KSP. Is that 0.4 elephants, aardvarks, angstroms? What is it? Not a Scooby-Doo. And loads of students do that. They forget the units on the uncertainty and you don't get the mark. Because we've not told us what thing you are uncertain in. Okay, you got to convey that you understand this. She's done another table, which is a nice bit of data processing. 5 temperatures, 2 decimal places, no uncertainty. She's averaged reciprocal of T, natural log, now we're to 1 dp, 2, 3 sig fig. So the number protocols, but the number protocols could be better within this internal assessment. She knows this. And then we get to the graph. Right, go students, what's wrong with that graph? Also, let's start. Let's be nice. What do we like about the graph? Ricky, what do you like about the graph? It's neat. Okay, cool. Thank you. Anything else? Tingu, what do you like about the graph? Absolutely. Missing uncertainties from the graph. Anything else that you're unhappy with, Bella? Look at this. After, like, what is that, 315 Kelvin, it's just meaningless. Okay, that's just, and that was that 10 to the minus 5, 10 to the minus 7, 10 to the minus 9 thing. Their data range was here, not here. Okay, so she has actually poorly controlled her variables. Okay, if you're in a situation like that, have a little think. Uncertainties and error bars. Then we get this. And you're like, wow. Mia, what do you like about that? Yes. Now the error bars. Let's have a little meditate on the error bars. What do we notice apart from the one that's missing? Good observation. Apart from the one that's missing, what do we notice about the error bars within this internal assessment? They're all different sizes, right? This is like that optical illusion game, isn't it? Which one's the tallest one? This one, I think that's the biggest one. Then maybe that one, that one, that one. Then I'll list the smallest from where I'm stood at the screen. But there's no calculation that tells you that. There's only one calculation here, since they're all 0.4, which it doesn't look like they're all the same to me. So while on first inspection, that graph actually looks pretty smart, like she's tried, and she has tried, this is unexplained. And if I don't know where the error bars came from, I can't give the mark for appropriate treatment of uncertainty within the internal assessment. The maximum gradient is clearly from the bottom of the first error bar to the top of the last one, and the minimum is the top of the first error bar to the bottom of the last error bar. Why do we do maximum and minimum gradients, please? Why do we do maximum? That's a start, not a bad answer. Any advances on that answer? So it gives us, you're saying it gives us an idea of the range of the data. What does that treatment of the data actually give me as the person writing up the internal assessment, and the reader as the examiner? What does that tell me? Where do error bars come from? How do we decide the size or the magnitude of the error bars within a graph? It's all from our reading error, otherwise known as our random error. So that's the things that we expect, the last decimal place. The half-range method, we've calculated entropy of combustion using the data booklet and compared it with the entropy of combustion in John Chewy's site and looked at the half the range. That's the reading error, that's the random error. So this is the error that we know about. We can reduce that by doing repeats, magic clicking on the button on WebMo, reduce that by doing repeats. But if my maximum and minimum error bar gradients do not go through all of my error bars, what that tells me is that my systematic errors are greater than my random errors. It means within my experiments, there are errors which I have not been able to calibrate for. Okay? So maximum, minimum, greater. So this tells me this one's okay, that's within the range of confidence of my data. This one's miles out, this one's miles out, this one's half in, and obviously the other one's totally in. This one is so far out, because we're saying we're uncertain to this degree, this is absolutely miles away. So why is that one so far away? But you can have a guess. You know, you're using different databases, different sources, different universities use different machines, different calibrations, different days, different source materials, different carrier gases. There's all these things that we need to consider, and that we can't control it. We can't hope to control that, but we need to show that we understand that there is different circumstances for each place that's gathering the data that we're harvesting in Lorong-Chuan, Singapore. So does that make sense on why we do maximum minimum gradients? You don't have to do maximum minimum gradients. They are not a requirement of IB chemistry. They're actually a requirement of IB physics. Okay? But I encourage students to do them, because once you've done them, it makes it so much easier in evaluation to talk about magnitude of systematic and random errors and get those full marks on the evaluation. Any questions on that graph? My main issues were, where on earth did this uncertainty come from? Why is there no horizontal or longitudinal error? Okay, top scoring IAs have top, left to right, and north south error bars, because you're uncertain in the temperature and you're uncertain in the KSP in this case as well. So it's actually done half the treatment. But the major issue with this IA is the choice of the range of data, and that's a fundamental. Fundamentals are often missed, so be careful when you stand back and reflect on your internal assessment. She's gone on to discuss trends. Trends are great. R-squared value is expected. I'm not just clicking the button saying the R-squared value is 0.41 or 42, some of the IA. But what's the significance of that? And how does that relate to it? What's the mathematical relationship? Is it negative or positive correlation? Is it exponential? What is it? Is it logarithmic? If it's logarithmic, explain why it's logarithmic. This one was. She's going to have a go at explaining why it was. Anomalies and uncertainties get their own paragraph. Brilliant. You've reflected on your data. You've told your marker you care enough about your trend to discuss the things which didn't fit the trend that you expected. Fight theory, and then this is from Andrew Weng. Do you all know Andrew Weng? Yeah, Andrew Weng's got a YouTube channel. Very good chap. Took some down, I put onto a page. This is his table. What's the limitation? What's the impact on results? What's the suggestion for improvement? The same as we tracked the variables at the beginning. The evaluation is both where students writing their internal assessment get tired, bored, got to finish my extended essay instead, want to go play, all these things, and it's often rushed. This is where students lose the most marks in evaluation. There's 6 available. You can get 4 just by doing this. You get 5 and 6 by doing maximum minimum gradients, talking about the magnitude of systematic and random errors and how you would reduce them. So what's the improvement? How would you reduce those errors? And she's got 1, 2, 3, 4, 6. There's one mega improvement that she could do to this evaluation. And the mega improvement is that the data gained from databases were inconsistent, unreliable, as conditions were not conducted and were not stated. Is that a systematic or a random error? Right, systematic, okay. So for each one, she has to go through random, systematic, random, say which one it was. Because on the graph, all we can calibrate for are the random errors, not the systematic errors. And if you've not calibrated for it, it will give you anomalies. And that's where the discussion becomes richer. So when you've got numbers which are outside your data set, I know you've got a bit upset about that, some people, but that's gold, that's brilliant. You can talk about it in evaluation and get marks for reflecting on the data honestly and truthfully. So 6 in evaluation. What's the overall conclusion and the suggestion for extension? Clearly, everyone will say more of the same. Okay, that's not bad, it's an extension. But what about approaching it from a different angle? If you looked at Van der Waals surface area, why did you look at dipole though? If you looked at molar enthalpy of vaporization, why did you look at molar enthalpy of sublimation or condensation? Or extend it more than just saying more of the same or more data points. That's not enough. And then she's got a lovely bibliography. Well, mostly lovely, apart from Course Hero and things. But she's put the links in for each of them. And moderators, when they're moderating, I know, will go in, copy paste that, and just have a look, quick look. Is that what the student accessed? On that date, she'll probably have the date, yes, what date it was viewed. And they are mostly academic, University of California, references, IUPAC, and I'd say, 6 to 10 academic references will show that you are personally engaged in your